This statement, believe it or not, is not meant to be uncomplimentary. It's intended to show that it's not easy to label C++, that often a lot of statements are made that don't stand up to much scrutiny. Maybe you've heard this one, that C++ is a superset of C. This is a label that's often given C++, and it is a superset. Well, nearly anyway. This description is usually given to reassure existing C programmers that their C programs are also C++ programs, that they can compile them with a C++ compiler and that they'll continue to run. But where this is misleading is that it implies that you can take your existing C code and practice, slip in a few new features, a little extra syntax, and you're now a C++ programmer. And that drastically understates what's involved. Let's look at another label that's often given to C++. That it's an object-oriented language. This description is usually for the benefit of those who are familiar with what the term means, that maybe have programmed in another object-oriented language. But again, the label is misleading, causing such ones to gasp, but it's horrible. It's nothing like Smalltalk or some other object-oriented language that they're familiar with. So we're going to latch on to another label, another description that's sometimes used. That C++ is a hybrid language. C++ is a mule. Now what does this mean? What is a hybrid? The term is obviously originally a biological one. A hybrid is a cross between two different species. The mule, for instance, is a cross between a horse and a donkey. And mules are bred to try and give us the best of both parents. We like something from over here and something from over there, and hopefully the best of both ends up in the hybrid. Now, the interesting thing about hybrids is something called hybrid vigor. They tend to be larger, stronger than either of their parents. The mule is bred for its strength. Many plants, corn, wheat, tomatoes that are grown commercially are hybrids because they yield bigger crops than would otherwise be possible. C++ is a hybrid language. It's a cross between two parents. It too has hybrid vigor, which is why it's so popular. So let's think about its parents. The first is C. C++ inherits from C a great deal of syntax. It is, as we've said, largely a superset of C, meaning that most of the C programs you've written are also legal C++ programs. You can take them and with a few, if any tweaks, compile them with a C++ compiler. And they'll run and work. Now, because C programs are to a large extent legal C++ programs, that's going to ease our progress towards C++. We can build upon our existing C expertise. Though, it's also important to realize that because we can instantly throw a lot of C code at a C++ compiler that it will happily accept, that does not make us C++ programmers. Because C++ is a hybrid language. And not only do we have to make the journey from here to here, but also from here to here. C++ also inherits from C, it's efficiency. Now, that doesn't mean that every C++ program you write will be blindingly fast, any more than every C program is blindingly fast. But the designers of C++ have always had one eye on efficiency. And where choices have had to be made, they've tried to adhere to the principle that you should only pay for what you use. In other words, if we take one of our old C programs and compile using a C++ compiler, the program should be just as fast as the original. As we add new C++ features, there may not be costs, but we will know ahead of time what they are and be able to decide whether or not the benefit is worth the price. So the goal of efficiency comes to C++ from its C heritage. C++ also inherits from C its portability. C compilers are available on, well, virtually any machine you care to name. C++ compilers are also extremely widely available. C++ also inherits from C its users. C has an extremely large user base, many of whom are eventually tempted to investigate C++. Now, this is an important consideration because commercial activity occurs where there are users. And when you need a particular library or support, it's much more likely to exist when a language is mainstream. Now, in this course, we assume that you already have a working knowledge of C, perhaps from our own C language video. We're going to tackle the journey from here to C++. So now I think we need to have a look at C++'s other parent. We could be more specific, but we've left this very general. We're simply going to describe it as OO, Object Orientation. And this is the area where most C programmers have most to learn. From here to here is a case of learning a little extra syntax, just a few new features and slipping them into your coding practice. That can be quickly learned. But because C++ is a hybrid language, because it has OO as a parent, we also need to tackle this journey as part of the course. And as we'll discover, this changes the whole way we program. Let me give you an example. C is a procedural language. In other words, our design is driven by code. We break the programming task into a number of smaller tasks and then break these into even smaller tasks, ad infinitum, until we have manageable chunks. Let's imagine a bank application, for instance. In this application, we're going to need to be able to place a deposit in our bank account. So we might start off with three functions. Enter transaction, because we need to be able to make a record of how much cash and checks we're going to deposit. Process transaction, which will deposit the cash. The checks are cleared somehow and our account is updated. Result transaction. Maybe we're given a receipt if everything went well. So having written these three functions, then we look at each of them and think about what steps are involved in each of these. So process transaction, for instance, might involve cash deposit and check deposit. Our design is oriented around code, tasks, functions, procedures, procedural programming. In an object-oriented program, the application is designed around data rather than code. Rather than breaking the problem into a number of tasks, instead, we identify the key data structures that will be needed within the program. Cash, check. Customer account, customer transaction. And we build the program around these. Now, how and why this makes a difference, well, we need to leave that to later in the course. What we need to note in this introduction is that it affects the entire way we program, turns it inside out, which explains why it usually takes several months for most C programmers to get to understand how the language works and how to put programs together. One final point about hybrids. They aren't always pretty. The mule is not the sleekest and the most beautiful creature on earth. It's bred not for its beauty, but to get a job done. C++ is also often criticized for its lack of elegance compared with other pure object-oriented languages, such as Smalltalk. It may not be pretty, but the reason it's successful and widely used is because, like the mule, it does the job better than either of its parents.